Good morning, guys. It's Miss Leggett, right? So just trying this out to see if it'll work to keep us connected. This particular stream is for my homeroom. It's not that you can't look at it if you're not in my homeroom. If you're in my period 3-4, that's okay too. Just realize that you'll have your own stream for period 3-4, and the stream that accompanies the class is going to be on the Google Classroom. So if you were part of this stream and you're in my period 3-4, you're not going to see this link. You're going to see your own link. And that one's going to start around 10:30, right? So for homeroom, I'm going to be trying to stream 9 to 10. This way you guys can ask questions. I'm trying to do this to make sure that if you guys have any questions about the math, any concerns, you can ask me right here. With math, it gets a little tricky because while you're working on the math, if you don't have someone you can ask right away, you can get pretty frustrated pretty quickly. So that's the point of this, as well as to keep our routine in the classroom. We've had a pretty good routine going on in class, and we're almost done. We're reaching our goals, and I don't want that to stop. So that's the second reason why I'm doing this. Keep us connected and keep our routine going. All right, so as you saw in the classroom, please make sure that you're checking announcements every day. And as per Ms. Rodriguez, make sure that you are committed to your work and dedicating at least 3 hours a day to your work, which it might sound like a lot, but it's actually not. The stream alone is going to be an hour. And then any follow-up work that you're doing on it will tack on some more time. So don't stress about that. Just stay on top of your work. Don't fall behind. And if you have any questions, you can you should be able to chat here, or you can comment when I post the link, or you can email me still in my district email. All right. So let's get started. We're going to get started just like we would in the classroom. I've got our goal posted, what standard we're working on, and we're going to start with a warm-up, and then we're going to get into our tasks. All right. So take a look at the warm-up real quick. I need you guys to either post in this chat during the live stream or comment on Google Classroom when I post the link with 3 equivalent ratios that are equivalent to 3 to 10. 3 to 10. Give me 3 equivalent ratios. I'll give you a couple of minutes for that. And if you were watching the video part, you'd be able to pause it whenever you like. That's another benefit to this. If there's something you missed, you could always pause it, replay. All right. Now, I'm not going to give the answers away. I want to see what you guys come up with. So I'm going to wait and check that out when you send it. And we're going to move on. We're going to go to task 9.3. So if you're in your, we're going to actually go over the quiz first. We really got to go over the quiz. You guys took a pop-up quiz on ratios. And it looked just like this. All right, that's how it started out. And we really got to go over that. The results were really good, actually, very positive. But we do have a few kinks to work out. And I think, honestly, a lot of the kinks are more just paying attention to detail when they're asking questions. So, for example, in number 1, even though they're showing you this diagram, and many of you circled the batches, which is not a problem. That's not a problem. The problem is you have to make sure that you answer the question. You have to make sure that there's some kind of answer statement. And then even though it says explain or show, and I know so many of you like to show, not explain, you still need to make sure that what you're showing is actually clear to the person looking at it. So if I simply circle my batches, And hopefully you guys can pull up your quiz right now. Remember, the pop quiz was in your Google Classroom. It's in your classwork tab. So view your work, view your grade. If you have any questions, you can ask me. I am human, I make mistakes. So if you see something that looks a little weird, just ask me. Okay, so let's pretend that this is what I did. And this was all I did. This is not enough. We have to do our answer statement. We have to actually answer the question, how many batches are there? And if you circle it, that's part of showing, but it's not the whole thing. Something that would be a lot better, I saw some of you do, you labeled those circles. You actually labeled them. Maybe you drew an arrow and you said batch 1, and you said batch 2, and batch 3. So that's closer to showing, because you actually label what you did. All right, so I want you guys to focus on that. I want you to zero in on what it's actually asking, and then I want you to make sure that your demonstration or what you're showing is very clear to the person looking at it. You can't think of it as, oh, this is Miss Leggett, she knows what it is. You have to think of it as like a complete stranger is looking at it, and would they be able to make sense out of it? So let's actually do our answer statement. You guys were all pretty much able to identify that there were 3 batches. So you have to actually say that. You have to say that there are 3 batches of, and what did they say? It's a recipe batch for spice mix. So there are 3 batches of spice mix represented by the diagram above. Represented by the diagram above. All right. There are 3 batches of spice mix represented by the diagram above. Now, this is where it gets a little tricky, because it looks like you showed, right? But the thing is that you have to say why. Why is it 3 batches? And you guys, I'd say about half of you were able to identify it. So let's be clear here. Why is this 3 batches? It's not just because I was able to put them into 3 equal groups. What's the other part of it? The other part of it is that for each ingredient, it's a multiple of 3, right? What's represented here? So if I'm talking about the mustard seeds, 3 times 3 is 9, and you have 369 total here represented. So 3 times 3 is 9, 3 times 3 is 9, 3 times 3 is 9. And then the same for the other ingredients. You look at your chili powder and you have 1, 2, 3, 4, 5. 5 times 3 is 15, and a total of 15 have been represented here. So for those of you who were able to say that there is a multiplier of 3 here, you got the full credit if you showed and you had your answer statement. And there was partial credit if you simply circled and labeled but didn't put your answer. Partial credit if you put your answer but you didn't explain. So there's partial credit. But with something like this, you guys know this. So I want to see you get full credit. All right, number 2. Number 2 says, Priya makes chocolate milk by mixing 2 cups of milk and 5 tablespoons of cocoa powder. Draw a diagram. So here we go again. Let's zero in on what the actual directions are. They're telling you to draw a diagram, which means they're expecting you to represent the ratio the way it was up here. There's a diagram here representing the ratio, and then you go down and you explain it. This time they want you to actually sketch the diagram. All right, so you got to zero in on the directions. What are they actually asking you to do? And this diagram that you sketch has to represent 2 batches of her chocolate milk. Well, how many did they give you in as information in the problem? They gave you 1 batch, right? Priya makes chocolate milk by mixing, right? You gotta think of it like in the past in class, when we saw recipes, I think it was the tuna casserole, they would actually just list the ingredients in some type of little clipping. They're not doing that here. They're simply telling it to you by words this time. So you have to kind of make the connection. Oh, her recipe is 2 cups of milk and 5 tablespoons of cocoa. Then that's my little clip. That's my recipe. That's my one batch. One batch is 2 cups of milk and 5 tablespoons. So I think what happened here is that some students got confused. Do I multiply this recipe or do I divide this recipe? Am I looking at 2 batches and I have to cut it in half, or am I looking at one batch and I have to multiply it? Well, I just explained that, right? We're looking at one batch and we have to multiply it. We have to show, what if she wanted to make more? What if she wanted she needed enough and she wanted the 2 batches because that would be enough. So then what you would have to do is you would have to show that. Now, some of you got pretty creative. So I want you to ignore my clipping on the side. I don't want you to think that that's part of my diagram now. So I'm going to have 2 cups of milk, and it's going to go with 5 tablespoons of cocoa powder. And I will shade in my milk, and I will label it. So I'm showing the one batch right now. I've shaded in to show the difference between the two, because one thing that I did notice is that a few of you you chose the same shape, or you didn't make anything different. If you notice, even though these are the same shapes, they're colored differently because they're representing something different. So you want something unique in each symbol that you use to represent the ingredient. So here we have milk. I shaded it in, so I have my 2 to 5. 2 milk to 5 cocoa, right? And just realize we have cups and tablespoons. Don't just put cups or tablespoons. Some of you did that too. I really need you to say what it is that we're actually comparing. We're not just comparing cups and tablespoons. To be specific, what are the 2 quantities that we are comparing here for this ratio? You should be able to tell me we're comparing cups of milk and tablespoons of cocoa powder. Okay, those are our 2 quantities that we're comparing. And what are the units? The units were the cups and the tablespoons. All right, now I'm showing one batch, but if I want full credit, I not only have to show the batch plus label it, I have to show a second one. So some of you separated it and some of you kept it together. I accepted both. 1, 2, 3, 4, 5. Okay, so I'm showing the 2 batches separate like some of you have done on the actual quiz. You can also do it the way they did it up here though, right? Because they kept it going and they put a little bit of space in between the batches. So ideally, it should resemble this one, but be labeled, and you see how they labeled it and they put the units right next to it. Miss Leggett missed out putting her units, so be better than Miss Leggett. Put your units next to your quantity, okay? And that's it. As long as you showed me 2 batches, I took it. And it has to be labeled. Make sure you label. Remember, that was something that we were trying to focus on when we were practicing with the DUA. Make sure that you're labeling your work. Okay, let's go to number 3. If you guys have any questions, I'm not seeing anything in the chat. So, and I am an amateur here. So if you guys are asking questions, I'm not seeing it. All right. I don't want to push anything and then do something weird. All right, let's just keep going. And if you guys have questions, I will do my best to follow up and improve it. All right, number 3. All right, number 3 is the fizzy grape juice. Now, this one went well, except for a couple of things. All right, we'll read it together first. In a recipe for fizzy grape juice, the ratio of cups of sparkling water to cups of grape juice concentrate is 3 to 1. This was one of the formats that we talked about. That you can write a ratio with words and numbers, a mixture, or you can write it the way they wrote, well, we didn't see that yet. Many of you gave your answer in the format with the colon, which was perfectly fine. But what happened is we didn't zero in on the directions. It says find two more ratios. So that's what I need you to focus on. It says find two more ratios. Some of you only listed one. And that's what I mean about, just trying to zero in on the directions. Because you don't want to lose credit for something that you know how to do just because you simply left something out. All right, so two more ratios. You could list any two that you want as long as they're equivalent. If it's going to make the same, all right, so that's something else that you have to zero in on. If it tastes the same, we're looking for equivalent ratios, because we want to keep the same rate or the same taste, right? We don't want to change the recipe, so we have to keep the batches the same. So many of you simply told me 6 to 2. Why? Why does that one work? Because 3 times 2 is 6, 1 times 2 is 2. And I think the other popular one that you gave me was 3 batches. So you told me 9 to 3. That was another popular one. Why does that one work? 3 times 3 is 9, 1 times 3 is 3. And please be very careful with your work and go back and check, because some people lost a little credit because they simply missed multiplying by both. All right, part B. Now, part B wants a ratio, but what's different this time? This time they want one that's going to taste different. Well, if we want something that tastes different, and we don't know why this person is making this fizzy grape juice, but maybe she knows that, whoever's making this, maybe, maybe they want a stronger grape taste, or maybe someone wants it a little watered down. Then that means you got to change the original recipe. Change the original ratio. So we're looking now for a ratio that is not the same, that is not equivalent. And I think almost all of you were able to do this. And for those who didn't, it's simply because you skipped the question, and that could just be an oversight. So please be careful. What I'm going to recommend to remedy that is to simply check things off or cross them off as you do them. So for example, let's say I'm on number 3. I can say, oh, okay, I answered number 3, so check. All right. And then when you're looking over your work, you see, oh, I didn't put a check by B, so let me do that real quick, right? Because you shouldn't lose credit on just something that you didn't do. Now, actually, for part B, you can give me any ratio you want. It could be absolutely ridiculous as long as it is not equivalent to 3 to 1. As long as it's not equivalent to 3 to 1, you are in good shape. All right. So anything there will work. What if I put 2 to 5? Would that work? Will that taste different? Is that a ratio that is not equivalent to 3 to 1? And how would you know? Hopefully this one pops out at you. 1 times 5 is definitely 5, but 3 times 5 is nowhere near 2. It's supposed to be 15, which means you don't have an equivalent ratio. So like I said, it could be completely ridiculous as long as it's not equivalent to 3 to 1 here. All right, let's go down to the last one. Now, the last one, and I can actually just take this part off. Okay, so this last one was just a matter of being careful with your wording, right? Because there's 1, 2, 3, 4 statements that you have to complete. You have to basically fill in the blank, right? At the kennel, there are 6 dogs for every 5 cats. Well, you can make something for yourself right there. Dogs to cats, just like we did in class, right? We would label it first. Dogs to cats, 6 to 5. So that's what we're looking at, dogs to cats, and it says 6 to 5. Now let's take a look at the different ways that they're writing this. The ratio of dogs to cats is, well, we just did that, right? Dogs to cat is. So what you should have put there is 6 to 5. Now they want to switch it up on you, right? The ratio of cats to dogs is, so if you reverse it, cats to dogs, this one has to go first now. Well, cats to dogs. And if it helps you, just write it right beneath it. I mean, don't make it, more complicated. If this is cats and cats represents the 5 in the ratio, dogs has 6, just write it like that. And then you could just simply fill in the blank. Okay, now this was another way we were talking about ratios. For every blank dogs, there are blank cats. Well, if you take a look at it again, dogs to cats, that's the original way that we wrote it. So just fill in the 6 to 5. And then once again, for part D, they're just reversing it again. The ratio of cats to dogs. Cats to dogs, just reverse your 5 to 6. I noticed with this problem that some of you, and I'll put up the last just in case you missed it. I noticed that some of you started to work on equivalent ratios here, multiplying or dividing, and you got to be careful with what they're looking for. They gave you a statement, and they're only looking for the different ways to actually say it, to actually write it. We could say for every blank, there's blank, or the ratio is blank to blank, and that's what they're doing here. They're just simply making sure that you're making sense of this statement right here. And I'm going to box it for you. That statement right there, they want to make sure that you can understand the different ways that we could write that and keep it the same, because we didn't change it. That's the important thing to realize here. 4 different ways to say the exact same thing to represent the same exact ratio. We did not change the number of dogs. We did not change the number of cats. We simply wrote it or explained it in a different way. We represented it in a different way. All right. So if you guys have any final questions about that, about the quiz, maybe about your grade, about any of the comments that I made on your quiz, please look at the comments, because I try to comment as much as possible if I saw a mistake or somewhere where you needed to improve. Okay. Just make sure that you could comment on the actual quiz. You can comment on the stream or when I post the link. I'm going to be posting this link for the many people who maybe were not available during this time. You guys got to try to be available during this time, though, because if we could figure out how to chat. Again, it didn't pop up. It's been popping up on my other tests, but for some reason it's not here. Then you can actually get your questions answered right away, and that's actually the point. All right, let's keep moving. So the next thing I wanted to do was 9.3, which is in your book. So I need you guys to go to lesson 9, activity 3. Okay, now this one actually has a digital version. So if you're able to, that would be great, because the digital versions help a lot. Remember, anytime that you see the barcode, there is a digital version available of the activity. So if you guys like that, you can use that. Make sure that you have something to write with, though, so that you can record this in your book, your answers. And I want you to take some time now, all right? I want you to take a look at this. Everybody should be on 9.3, moving for 10 seconds. Moving for 10 seconds. Lynn and Diego both ran for 10 seconds, each at their own constant speed. Lynn ran 40 meters and Diego ran 55 meters. All right. So we need to talk about a couple of things before we start talking about how we're going to answer any of the questions that they present us. So the first thing I want to ask you is, what do you notice about this problem? There are a couple of things that you definitely should have noticed. All right. So, and I'll box where I'm trying to draw your attention. I want you to focus simply on the beginning information, what I boxed. Focus on that and tell me what you notice. All right, hopefully, because again, I'm not seeing anything on the side here. Maybe you're quiet, shy, I'm not sure, or maybe it's like a technical issue and it didn't pop up. So first thing you should be able to notice is that Lynn and Diego ran for the same amount of time. And that's very significant. They ran, it's almost like a race, right? Someone says, okay, on your marks, get set, go. They hit the stopwatch. They go for 10 seconds and then they stop it, right? Nothing that they do after that is going to count. It's strictly for 10 seconds. It's the same for both of them. But what's different is that they ran different distances. So hopefully you notice that also. They ran for the same amount of time, but something happened, and where they've stopped and measured, Diego ran for 55 meters, Lynn ran for 40 meters. All right. Now there's one more thing I want to talk about, because we have not brought this up in class, and that is the phrase constant speed. What does that mean? If something is constant, it doesn't change, right? It remains the same. Okay. So, but now, honestly, that's partly realistic and partly not realistic, right? Because if you're driving in a car, you know that even though someone could be going 50 miles per hour 1 second, they slow down because something's going on, or they are on an incline and it's 45 miles per hour. And then they want to pass someone, so maybe they scooch back up to 50 miles per hour. It's always changing, really. But mathematically, we're going to study when things stay the same here. All right. And that's just Lynn and Diego staying the same. All right. Number one, who is moving faster? And how do you know? So you're going to have to explain. If you have a gut instinct reaction, jot that down. Who is moving faster and how do you know? Now we're going to actually end up drawing a double number line here. We are going to draw a double number line, one for Lynn and one for Diego. That's something that I need us to do, even if you can answer the question without it. Okay, so hopefully you guys said it was Diego. Hopefully you guys said that it was Diego, and why? For the same amount of time in 10 seconds, Diego actually ran farther. All right, now you might have been tempted to say, oh, wait, it's got to be Lynn, right? Because when you think about quicker or faster, you think about who took less time to go the distance, but they kind of reversed it. They kept time the same. So you got to be careful. He ran farther than she did in the same amount of time, which means he had to be running faster. think about, in this case, don't think about them having the same finish line, because they didn't. They didn't finish in the same distance. A lot of times when people are racing, you think of that whole flag getting twirled and going down, okay, and they're like, okay, that's it, you crossed the finish line. But that didn't happen here. What happened here is, if they were both on a track or anywhere, maybe you guys say, oh, let's race, and who can get to that first? Instead of doing that, you're running a stopwatch for 10 seconds and you want to see who could go the farthest, who can just keep going, and in 10 seconds they freeze, and whoever was farther ran the fastest. All right, that's kind of the idea here. So who is moving faster, and explain or show your reasoning. So what we're going to actually do is we're going to create a double number line. All right, I said that we were going to do that. So let's try to do that a little bit. Now remember, with the double number line, we have to make sure that we're labeling. All right, so no matter what you do, right, no matter who you put, like let's do one for Lynn first. Okay, so if this is Lynn, and hopefully that's enough. The two things that we're measuring here are what? What are the two quantities here? We have distance and we have time. And in Lynn and Diego's case, it's actually meters and seconds, right? Those are our units. So let's put the meters and let's put the seconds. Now, this part is the same. If the timer didn't start, then she didn't go anywhere. That part you could rely on. The information that's actually given to us is that in 10 seconds, she ran 40 meters, right? So in 10 seconds, she ran 40 meters. 10 and 40 have to match. Remember that. Let me circle that for you. Because I want you guys, it's a detail that we can't leave out. They have, on a double number line, they have to line up and they have to match. Now you have a lot of options here. You have a lot of options as far as where you want to go from here. What are we interested in? If we want to prove it, take a look at number 2. How far did each person move in 1 second? This is part of the proving. If you know how fast each person was moving, if you have their rate or their constant speed, what are they constantly moving at? Then you can prove who actually was running faster, because they're keeping that rate for the full 10 seconds. And if they keep that rate for 10 seconds, and then the other person's keeping their rate for 10 seconds, you'll know who actually is traveling faster. So what are we actually interested in here? Well, what was the title of the task? It was constant speed, right? So we're looking at, we want to know how much, or how far, I should say, is Lynn going in just 1 second. How do I get from 10 to 1? On this number line, how do I get from 10 to 1? What would I have to do? I would have to divide by 10, right? So from here to here, if I divide by 10, then I need to divide by 10 here also. So to get from here, to find the one that matches with that, divide by 10. What's 40 divided by 10? So right away, now you're probably saying, well, we didn't have to do this double number line just to find that, and that's okay. But when you start thinking about DUA, and the fact that you really want to choose a model that is going to completely show your reasoning and your answer. When you simply do, like, we just divided by 10 and we got the answer. So, you know, when you just on the side, when you just do, you know, the 40 divided by 10 and you get 4 and you're like, oh, well, she's going 4 meters per second, right? You know, it's great that you know what to do to calculate, but how are you showing how the distance and the time are related? How are you showing that it's constant speed? And how are you showing that it's different from Diego? Because Diego was the one that was running faster. So this is where it just gets a little bit more sophisticated, and you really show that you understand the math that you're looking at. And what math are we looking at right now? Well, we're in the topic of ratios, right? And we're looking at ratios and how they're connected or seen in constant speed. And then think about the ways that we've represented our ratios. It's been words, it's been the format with the colon, it's been in tables, it's been in double number lines. It hasn't been in scrap work or scratch work where we just do 40 divided by, right? We always show that there's a multiplier or some kind of, you know, we're doing the same to both. So over here, you can see that I'm doing the same to both. I divided 10 by 10 to get this. I divided 40 by 10 to get that, right? And then you can actually even complete this. You can complete this so that there's more here, like about halfway. Let's talk about halfway. Now, if I cut 10 in half, 10 divided by 2 is? 40 divided by 2 is? See, so you can start filling it in and make it complete. And I want you guys to try that. I want you guys to try filling the rest of that in. But I'm going to get through the problem first, okay? So overall, Lynn was traveling at 4 meters per 1 second. 4 meters per 1 second. Now let's take a look at Diego. All right, let's take a look at Diego. Let's put him in a different color. So we're going to do the same thing. Hopefully you guys can see that. Good. I still want you to label this, right? This is Diego. And it is still distance and time. Distance is still being measured in meters and seconds. Be careful, because as you get older and the math gets more sophisticated, they will switch units up on you. Maybe even in 6th grade, you might have to convert some stuff before you actually compare them. Make sure that the units are the same. So once again, if the timer has not started, Diego didn't go anywhere. But he was timed the same amount that Lynn was. So we know that in 10 seconds, he was able to run 55 meters. And we could do the same thing that we did for Lynn. We're interested in a unit rate or a constant speed. We want to know how far is he traveling in just 1 second. So 10 divided by 10 will give me my 1. And that's how I know to divide by 10, because I'm interested in just 1. 10 divided by 10 is 1. So what is 55 divided by 10? Hopefully you guys have 5.5. Which means his constant speed, or his rate that he was running at, was 5.5 meters per 1 second. So in number 1, who was moving faster? Diego was moving faster. How do we know? Well, because he went farther in the same amount of time. But for number 2, they want to get more specific. They want the proof to be very specific here. How much for 1 second? If these two kept the constant speed, it doesn't matter how much time that they're moving, he's always running at a faster rate. Lynn might have said, hey, I need more time, because you know how people feel when they lose, right? When they don't go as fast, or they lose in rock, paper, scissors, shoot. Oh, one more time. Well, in Lynn's case, it doesn't matter if they ran for a minute, 10 minutes, 5 minutes. If we're talking about constant speed, that is our key phrase here, folks, constant speed. If their speed stays constant for each one of them, it doesn't matter how much time they're being clocked for. Diego's just always going to run faster because his speed is faster and it's constant. Now, again, that's not realistic. Things change all the time in our world. And honestly, if you actually look at racers in the beginning, you're not running as fast as you are probably middle, right? Because it takes time to get to that constant speed. But mathematically, we're looking at constant speed, and mathematically, we could say this. We could do this if it's constant, if it's always like that. All right. If you guys have any questions, I want you to just comment. Make sure that that's filled out in your book. Let's skip number 3. I want you to look at number 4 because I want to be able to. I wanted to be able to take questions from you guys. Okay. Han ran 100 meters in 20 seconds at a constant speed. This is number 4. Is this speed faster, slower, or the same as Lynn or Diego's? All right. We skipped number 3, so you could cross off yours. So let's check it out. What do you think? We already know Lynn's. We already know Diego's. Take a minute and see if you can create a double number line that is actually going to show Hans. All right. There's a tiny bit of space here, so I'm going to do that. All right, so this is Hans. Make sure you label your double number line. Everyone should be sketching that right now. Don't wait for me to do it. You got to try it. We still have distance and time and meters and seconds. But he went 120. You got a lot of options here. They didn't make you get a unit rate for him. I'm going to ask you for his constant speed, right? So if you have a couple of options here, but I want you to at least do 2 things. I want you to at least take us from Han. I want you to take us from the 20 seconds to the 10 so that we can compare all 3. Lynn went 40, Diego went 55. How far did Han go? If you did your double number line, you would divide 20 by, how are you going to get to 10? Divide by 2. All right, so 20 divided by 2 takes me to 10. So what's 100 divided by 2? Gives you 50. So let's put that up here on our board, and let's put it, I guess, put it in red. Let's put Han up here. In 10 seconds, let's put it over here. For Han, in 10 seconds, he went 50. He went 50 meters in 10 seconds. So give me the summary here. He's not as fast as Diego, but he's definitely faster than Lynn. Now let's take it. Let's get his constant. Let's get his constant speed, guys. Let's get his constant speed. Hopefully you have that already. Now you can use whatever data you have there as long as you get to 1 second. So what did you do? 10 divided by 10 is 1. 50 divided by 10 is 5. Nice numbers, right? Let me show you the double number line that I created. Okay, it's not gorgeous, but it gets the job done. You can fill it out more. Okay. Now, that means we can put him up here. He is running 5 meters per 1 second. And now you can compare all three that way. And you can say, okay, well, he's going 5 meters per second, and 5 is more than 4, but it's less than 5.5. So everybody has to at least say in this story, right? You can't just put all this there. You have to actually write the sentence out. So write the sentence out to answer. It says, is this speed faster, slower, or the same as Lynn's? Diego's, yours. So go ahead and write 2 sentences. Han is traveling faster, or his speed is faster than Lynn's because he's going 5 meters per second, while, or second sentence, his speed is slower than Diego's. Because Diego's is how much? How much faster is his constant speed? 0.5, a half, right? Half a meter per second more than Han's. So 2 sentences or compound is fine too. All right. I want you guys to do the practice problems for lesson 9. So I'm actually assigning that, and I'll put it on Google Classroom. You are going to do all of them, 1 through 7. Okay? Do that for homework. I'll post it on Google Classroom. I will put it in OnCourse. I am almost up to date with all the grades. I still need another day or 2, and I should be all done. And if you see any discrepancies, just make sure that you reach out to me, okay? Especially with MobyMax, you have to email me that you completed it, because I do get notifications, but sometimes they clump the notifications, and I could only see a couple of students and not others. All right? So if you have any questions, please ask me. Otherwise, I will stream again tomorrow during class time, 9 to 10 again. And hopefully we can get the chat going, because it's still not up here. So if you guys are chatting to me, I'm not seeing it, and I apologize. We'll figure it out, okay? All right. Make sure you check your classroom every day, every single one of your classes, and I will be posting the art classroom code for you to join. So please, 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 please take a look at your classroom streams for notifications, assignments, any kind of information. All right, all your classes. All right, stay safe.